Hey guys, we're going to go through a quick exercise in recursion in Scratch. So the other day my daughter was talking about how her name Aiden, spelled backwards, is Nadia. An interesting recursion problem that comes up a lot in computer science is that of a palindrome. And a palindrome is basically a word that spelled forward is also spelled the same backwards. An example is mom, M-O-M. So we'll get into the code in just a little bit. Let me show you the program to see how it works. First, when you click run, it asks you what is your palindrome, and the purpose of the program is to tell you if the word that you enter is or is not a palindrome. So what we can do is type in K-A-Y-A-K, kayak, and it'll go through the recursion and eventually spit out if it is or is not a palindrome. So here, kayak is a palindrome. And before we get into the code, let's just go through the algorithm a little bit. So we want to talk about exactly what's going on here. With recursion, you have essentially it's a function that calls itself, and it's like peeling back the layers of an onion. A recursive function has two parts. The recursive part, which is the part that calls itself. That's essentially how to get to the next layer. And then it has a base case. So essentially what happens when you get to the middle or the end of the onion and you need to figure out what to do when there's nothing left. So let's look at the recursive solution to a palindrome. You have to have a couple rules here. So the first one is if the length of the string is less than 2, then yes is a palindrome. So that's our first rule that we'll go by, and that's basically when we get to the very end. And the second one would be if the first letter and is not the same as the last letter, not a palindrome. And what this is it's basically an early exit. So if we go back to the onion analogy, if you're going through the onion and you find a bad part of the onion, we'll just exit. And so this is the thing that is also a base case that tells it that it's not a palindrome. So we'll put that here as another rule. And then finally, what's the actual recursive part? The recursive part is cut off the first and last letter and repeat. So when you go to do a recursion, you have to do it with less than what you started with, or else you'll just be recursing forever. So here we cut off the first and last letter. So let's go through this with the word racecar, with these three rules. So essentially, is it less than 2 characters? No. And are the first and last letters the same? Yes. So we need to go to this recurse part. So we'll take the word and we're going to take the first and last letter off, and then we're going to repeat. Okay, so I took the R's off. So is it less than 2? No. Is the first and last letter the same? Yes. And then we can keep going here. So we'll need to recurse again. So what we do now is chop the A off. And now we have CEC. Is the length less than 2? No. Is the first and last letter is okay? Then we recurse again. So we go here, and now we chop off the C's. And finally, we're just left with E. So we hit the if length is less than 2 condition, and it turns out that this is a palindrome. So that would be how our algorithm works. So if we go back here, we can actually see when our program runs. If we run racecar, it says ACEA, CEC, E, and then finally it says yes, it's a palindrome. Now let's go through the code and talk about the recursive solution that we're going to build. The main function was what we'll start with, and it is essentially just what interacts with the user. So it'll just ask a question about what the palindrome string they want to enter is, check the answer, and then tell them if it is or is not a palindrome. So we can start off with your typical when green flag is clicked, and then we'll go to sensing, and you can ask a question. So we're going to ask, what is your palindrome? And wait. What we'll do next is we'll create a block. So this is our special function that's going to do all of the work. We'll call it check pal. So check palindrome. And it'll take an input. So we'll add a little input here, and we'll call this pal. And that'll define a block. We're not going to actually do anything with it, but we'll just set it aside. And we can now call this function, check pal. We need to give it an input, so this will be what the user has entered. If we go back to sensing, you have an answer here. So we can do check pal answer. And then all we're going to do is check pal will return a variable called isPal. So make a variable for this sprite only isPal. And we're just going to set it equal to the string true if it's true, or false if it's not. So we need an if statement. Actually, we need an if else statement, so we'll pop that in here. And this is pretty simple. It's just if isPal. Oops. So we need the equal operator. So if isPal is true, then we will say, and in order to do strings, we'll have to do a join function, and that's a way to concatenate two strings together. So we're going to say answer is a palindrome. Yeah. And then let's duplicate this block and put it down here. And all we have to do is, if it's not one, we will just reword it here. Is not. And that's all there is to the main function. And let's go ahead and we'll define the check pal. We're going to follow our algorithm that we defined earlier, and in that algorithm there were 3 rules. So we just have to define those 3 rules. And doing so, we'll need some if statements. So we're going to do an if else. The first rule is if the length of this string that we're entering in is less than 2, then it is a palindrome. So how do we represent that? We need a operator, and we will go with less than, and what we're doing is less than 2, and then we just need the length of the string. So if you go here, here's length of, and pal is what's coming in. So if the length of pal is less than 2, what we can do is set our isPal variable to true. And when it gets there, if it's true, then it'll say it is a palindrome. Now our next sort of base case is if the first letter does not equal the last letter, then it's actually not a palindrome. Okay, so we need to make another if condition to represent this extra if clause. So we'll do if else and just nest it. Now, so I'm saying if the first letter is not equal to the last letter, to do the not equals, we need to grab the first thing is this not operator. So if not. And then we're just going to look, now we can look at the equality of the first character and the last character. And so there's a function called letter blank of string, and that's how we'll get the character. So letter 1 of, and we'll drag pal down here. So letter 1 of the string is the first character, and that has to not equal, or if that would not be equal to by this not expression. Basically the end of the string, right? So let's pull letter of pal, but now we need the end of the string, which is essentially the length of pal. Okay, so that's kind of a fancy expression that just says the first character not equal to the last character. And we can just duplicate this, but now it's going to be false. So set is pal to false. And so those are the first two rules, and then the last rule is just the recursive operation. In the recursive operation, what we need to do is reduce the problem and call itself again. To reduce the problem, we basically are going to take a substring of the pal and take the first character off and the last character off. That's not a function available in Scratch, so we're going to make a block that's going to do this. So we'll make one more hidden block called chop ends, and it will also a variable called pal, and that'll just chop the first and last characters off. So what we'll do is, in our recursive statement, we need to reduce the size of the problem. So we're so we'll pull chop ends down, and it will take pal, and then chopped ends will basically return a variable. Now you can't really return a variable in Scratch, so we'll just pass it this variable. And I'm going to make it chopped. So that'll be a string that comes back that's at the first and last characters popped off of it. So if you look at what's coming in, so we'll chop the ends, and that'll return a value or set a value in this variable called chopped, and then we'll check pal with chopped. So check pal is we're going to recurse back up here, and it'll do the repeated operation. Okay, let's go ahead and define the chop ends function. So the first thing we'll do is define or set the variable chopped to the empty string. So we're going to build this up from scratch, and it'll just be the string that comes in pal without the first and last characters. So we're going to define a variable called count, and start off with count equal to 2. So we're going to skip the first character, and then we're going to loop through. So we'll do a repeat until and grab our count variable. Oops. So this is, we need to grab the greater than condition, and then we're going to repeat until count is greater than the length of pal minus 1. So we're going to go ahead and put the minus in here. And here's your minus 1. And then we just need length of pal. Oops. Length of pal here. Minus 1. So then, inside the loop, we will start to build up our variable again, and we'll do set chopped to, and when you start to build up your string with concatenation, you use the join operator. So we're going to join chopped with the next letter in the sequence, which is essentially the letter count of pal. And then we will change the counter by 1, so we'll just increment our counter. And then at the end, I just want to show the what the recursion is doing. So in here, we'll just put think for 2 seconds, and then what we want to do is think, use the join operator, and we want to, whoops, say checking, is this a palindrome?
Make sure to like and subscribe. See you next time. Bye.